So hi students, so today we'll deal with the module 4 in physics. That is Cyrogenics. I'll be sharing the module. Yeah, I think you can see the PDF. Yes. So Cyrogenics is nothing but it's a branch of physics which deals with the production of at a very low temperature and their effect on matter. In the sense, what I want to tell or convey here is we have all learned about oxygen as in gaseous state, correct? But say with the help of this technology, we can convert it to what the liquid oxygen, liquid nitrogen, and all of those things. Okay, so obviously in this particular process, the temperature range is near to 0 Kelvin. Okay, it's near to 0 Kelvin. So obviously the gas will change into liquid mostly. So in the normal temperature of the Cyrogen products is of minus 150 degrees, which is minus 238 degree Fahrenheit to absolute zero. Correct. So this is the normal temperature. And the first thing for us is Joule-Thomson effect. So it's also called Joule-Kelvin effect. So there is a small derivation for the same. So this is the temperature. Okay, so we can see here the iron is melting at what 10,000 Kelvin. Correct. And we are getting liquid hydrogen at what 100 Kelvin. In a 10 Kelvin, we are getting liquid helium. So all of these are all what the cryogenic technique that Joules and Kelvin has discovered. And there is an important derivation which will come for the exam. So this is the one. Theory of Joule-Thomson effect. So this is a very important derivation. So whatever I said earlier, that is not that important, but now the important things will start from this. Okay. So we have to know first thing is work done formula. So work done is what? Internal work done plus external work done. So that we have to know first. And one more thing is ideal gas equation. We all have heard about it or done it in class 11th or class 9th or class 8th. So what is my ideal gas equation? PV is equal to nRT. Correct? PV is equal to nRT. I think everyone will easily recollect. PV is equal to nRT. Correct? So here it is what? PV is just, listen, only one thing. Work done is internal work done plus external work done. Second thing is PV is equal to nRT. Okay. So first thing we'll do the external work done by the gas. That is my P2, V2 and P1, V1, where P1 and P2 are pressure. V1 and V2 are the volumes respectively. So this is the external work done. Now the internal work done will be getting through the integration. Okay. And one more thing is pressure formula. Correct? This is nothing but A by V square. This is not Q. This is A by V square where A is a constant. Internal work done, I told you we'll be doing the integration from V1 to V2, change in volume. Correct? And P dot dV. And my pressure is what? A by V square. So we integrate 1 by V square. A is taken outside here. Correct? V 1 by V square. So V power minus 2, it will go to top. So we know that 1 by V square integration is what? Minus 1 by V. So that you have to do it. And then upper limit minus lower limit. If you do, you'll get this equation. Total work done is nothing but internal work done plus external work done. That is P2 V2 minus P1 V1 plus the above thing. So you have to go along with me and you write it down also. Then only you'll be able to get down. So if you just listen, we will not be able to capture any of what I'm saying. So this is the external work done. So parallelly you have to do that. Okay, so pause the video and parallelly do it. P2 V2 minus P2 P1 V1 plus this answer. So our first equation is done. Correct? Now, I told you to remember what? PV is equal to nRT. Correct? So this equation, I think a lot of people cannot mug up. That is P plus A by V square into V minus B is equal to RT. This is the van der Waals equation. Okay. So it's good that if you are able to remember it. Okay. If you're able to remember it, then we'll get PV is equal to RT plus PB minus A by V. So we got two pressure and two volume, that is P1, P2 and V1, V2. That is P1, V1 is equal to, for P1, V1 it is RT1, P2, V2 it is RT2. That's only difference. So I'll also tell you the shortcut or how to learn it faster also. So once we are substituting this P1 V1 value and P2 V2 value in the above equation, you can see here no P2 V2 and P1 V1. Here we are doing the substitution. We know that PV is what? nRT. Correct? N is equal to 1. So PV is equal to RT. So if it is P2 V2, just substitute R into T2 minus T1. R into T2 minus T1. Okay. Yes. And then we are having A by V1 and here also A by V2. Correct? Yes. So this is one way we can remember. But the other ones, we are having the constants B, correct? As well as A by V1 is also there here. A by V1 and A by V2. Okay. So one way of remembering is PV is equal to RT and RT. R N is equal to 1, we'll get this thing. R to T2 minus T1. But the other things, obviously, we'll be able to get it from where? From this equation alone. From this equation alone only we can get it. So substitute whatever is there in the equation in this, the below. So again, you have to work it down. Then we'll be able to get it. Then we'll be getting here 2A and 2A. So again, I will tell you, this is not QA or QA. This is 2A and 2A. Okay, so the handwriting is pretty bad in this. So this is 2A and 2A. The same thing what I told, PV is equal to RT, P1, V1, RT1. So from this again, we can find V1 and V2. Fine, and then we will substitute where? Here V1 and V2 is there, right? In the equation 5. Here I'm going to substitute these two equations. So I'll be getting what? W is equal to R into T2 minus T1 minus B into P1 minus P2 by plus 2A by RT into P1 minus P2. Once you substitute everything. This is not pi, this is again T1. This is not pi, the same equation T2 minus T1. I'm only substituting values of V1 and V2. That too I'll be getting through PV is equal to nRT, the ideal gas equation. Okay, next change. Change is always delta. So this is dot T. Dot means partial differentiation, or we can write delta T. So instead of T1 minus T2, you'll put what? Delta T or dot T. Correct? So my work done will be minus R dot T. The rest of things will be same. So instead of P1 minus P2 also, you can put dot T. Okay, so not P1 minus P2, it is T1 minus T2, you can put dot T. So P1 minus P2 will be common in this. And I can take what? 2A by RT minus B minus R dot T. That's it. Next thing is the heat loss by the helium gas. Okay, the C subscript V dot T. C subscript V dot, that is the heat loss by the gas. So CV dot T is equal to, instead of work done, I'll put CV dot T. And find out what is dot T. So everything by CV will come. Okay, so find out dot T in the sense we have to do what? This minus R dot T is there, no? That will go to the left hand side. So it will become plus. So again, if you want, pause the video and do it at parallel with me. This will go this side. I'll take dot T outside. So CV plus R. This will go to the denominator. Dot P is nothing but change in pressure. P1 minus P2, they have put as dot P. That's it. Now instead of the CV plus R, they'll put CP. Then I'll be getting the Joule-Thomson coefficient. That is delta T by delta P. So it's basically, this is the Joule-Thomson coefficient is what? Mu JT. Joule-Thomson coefficient is 1 by CP into 2A by RT minus B. Okay, how I'm getting is, this is basically my dot T by dot P or delta T. Okay, either you can put delta, dot, or a triangle symbol delta also you can put. This is my dot T by dot P. That is my Joule-Thomson coefficient. So if I'm dividing by dot P, this dot P and dot P will be cancelled. So I'll be getting this CP. So this is the important derivation in this chapter. And temperature inversion, I think the temperature at which the Joule-Thomson effect changes sign is called a temperature inversion. Okay, at this time, what happens? 2a, this is again not qa, this 2a by rt1 is equal to b, but t1 is equal to 2a by rb. So this is the temperature inversion coefficient of the Joule-Thomson effect. And the Joule-Thomson effect theory will definitely come for the examination. The next one is liquefaction of gases, which I already told you that obviously the aim of this aerogenic is technology is nothing but what? To get liquid oxygen, liquid helium, and all of the things, correct? So this is about liquidification of oxygen by cascading process. Cascading nothing but layers. There'll be there'll be three layers. Okay, so we can see in this diagram, cold water will get cold hydrogen, liquid methyl chloride, liquid ethylene, and in the bottom we will collect the liquid oxygen. So we have three compressors also. Okay, one compressor will give gaseous methyl chloride, other will give gaseous ethylene, and other is giving oxygen gas. So I'll be collecting the liquid oxygen in the bottom. So obviously, the meaning of this is basically what liquefaction, so conversion of gas to liquid. Again, we cannot by heart anything, but do note down the diagrams. So that's it, guys. Then, thank you.